Okay. Where is the pit stop? Slide. First order system. Okay. So first order system or sistem tertib pertama is we judge based on the transient response and steady state response. Okay. So let's say you are given a GS, the transfer function. Okay. GS with the equivalent transfer function as A over S plus A. Okay. And the input is RS and the output is CS. So we know that from here, the poles value will be S plus A equal to 0. So S is equal to minus A. Okay, and the location of the poles is on the left hand side of S plane. So this is considered as LHS, left hand side, sebelah kiri. And then this part is right HS, right hand side. Okay, and in between left and right hand side is the imaginary axis. Boleh faham? And this is known as S-plane. Okay, so sigma stands for real axis, and J omega stands for imaginary axis. Okay, so CS equal to 1 over S, where R is 1 volt. Kalau Laplace, so you will get 1 over S. Okay. So 1 over S multiplied by A over A, S plus A. Then we apply the partial fraction expansion. Then we apply inverse Laplace. So we will get 1 minus exponent minus AT. Okay. So when T is equal to 1 over A, okay, so you insert the value here, 1 over A, here. Okay, so A will cancel out, E will cancel out. So 1 minus 0.37, so it will give you 0.63 volts. Okay, so when we plot this one, so we will get a graph that represented by this blue line. Okay, so this graph is a response of the first order system. Okay, and the time constant is represented by this one, tau, which is equal to 1 over A. Okay, and it is happen at here, 0.63. Okay, or 63% of the steady state output. So the steady state output is here. Okay, which is equal to 1 volt. So 63% multiplied by 1 volt, what do you get? Syuhada. 63% multiplied by 1 volt. How many volt do you get? Syuhada? Tak datang. Aisyah Soleha?
Hello.
Ha.
Saya Syuhada.
Syuhada.
63.
Percent multiplied by 1 volt. How many volt do you get?
63.
Tak faham lah tu. Aisyah Soleha?
0.63.
0.63 volt. Okay, 0.63. So remember, time constant, okay, is the time where occurred 63% of steady state output. From the graph, steady state output is 1 volt. So 63% multiplied by 1 volt. 63 divided by 100 multiplied by 1, so 0.63. And the corresponding time is tau. Okay. ER is a rising time. Okay. So rising time is here. 90% of the steady state output and 10% of the steady state output. Okay, so the distance here from here to here is known as rising time, and settling time is plus minus 2% of the steady state output. So time constant, I repeat again, is the time for step response to rise to 63% of its final value. So speed of the system respond to the step input, and is the time for exponent minus 80 to decay 37% of initial value. Sama je lah, balik. Okay. Parameter A is a exponential frequency, which is a unit is 1 over per second. So is a pulse value at minus alpha, generate response at k exponent minus alpha t. So to further the left pole, okay, if you move this pole to the further left, okay, the faster the exponential transition point will decay to 0. Okay, so ingat ayat ni lah. The further to the left pole on the negative real axis, the faster exponential transition response will decay to 0. Rise time is the time for the waveform to go from 10% to 90% of its final value or steady state value. Okay, so in this case, time at 0.9 or 90% of the steady state minus time at the output is 10% of the steady state. So you minus, then you will get the rising time. And the settling, and then the rising time. Or the formula is 2.31 divided by A, 0.11 divided by A, so 2.2 divided by A. This is the formula. Subject to that, you know the value of the pulse. Then settling time is the time for the response to reach and stay within plus minus 2%. Which one comes first? It can be plus 2%. It can be minus 2%. So in UTM, we apply plus minus 2%. Okay, so 5% we don't apply. We apply plus minus 2%. So if the steady state output, okay, if the steady state output is 1 volt, okay. So what do you understand by plus 2% and minus 2%? Anurafika Balkis.
The range
Minus
the range is from 1 volt minus 0.02 until 1 plus 0.02. That's all I understand.
So how are we going to find in the graph? For example, in the assignment, how are we going to find
The
time though?
hypotenuse?
Apa tu?
Yang 3 segi tu.
Segi. Pythagoras.
Ay,
Cerita apa bah? Itu bukan Pythagoras bah. Tengok sini. Ni kan. Inputnya 1 volt. Dan responnya okay. What do you mean by plus minus 2% of steady state value? Steady state value berapa? Okay.
1 volt.
Plus 2%? 1 volt?
1.02.
Huh? 1.02.
Yeah. 1.2.
Minus 2%?
0.98.
Jadinya dia berada di sini. Plus minus 2% tu. So dia akan it will see either plus 2% or minus 2% by approximation. Okay. So when it goes to the it goes up here, so we will see 0.97, 0.98, 0.99, or 1.00, 1.01, 1.02. So which one comes first? Either this one or this one. Okay, as a settling time. Or we can simply use settling time is 4 divided by A, provided you know the A value, the pulse value. Rising time 2.2A. Okay. Example. First order unit step response is given below. Identify K and E. K2 is the gain value. K is the gain value. And A is the pulse value. Okay. So what we should do? First is we plot it using a partial differential equations. Okay. K divided by A minus K divided by A, where Rs is equal to 1 over S. This one, 1 over S. Okay, so you multiply with this, then partial fraction expansions, so you will get this. So in order to find C of T, you apply inverse Laplace transform. Then find C infinity. You replace T with infinity, so you will get 0.72. 0.72 is the steady state output, okay, which is here, steady state output, 0.72 volt. Okay. So 63% of the 0.62, 0.72 is what? 63% multiplied by 0.72. Berapa?
0.45.
0.45. Okay, so find the 0.45 value at the output. So it is here. Here, then use your ruler, tap here and go down. So this is the tau. Okay, so tau is equal to 0.15, more or less. Okay, approximation. So A is equal to 1 over tau, which is 6.7. So you already get the value of A, 6.7. Okay. So dia macam reverse modeling lah. You dapat output, you have the output, and you identify the output. Okay. Find the parameters value. Okay, 6.7. And then, so this is the response. And K value. Okay, so since you have A value, and this one is okay, K divided by A is equal to 0.72. A is equal to 6.7 equal to 0.72. So K is equal to what? The answer 0.72 multiply 6.7 berapa?
4.8.
4.8. Okay, so 4.8 you insert here. This one is 6.7. Okay, so now we have the transfer functions, which is equal to C over R 4.8 S plus 6.7. Boleh faham tak ni? So macam mana kita nak dapatkan graf ini? This graph using MATLAB. How are we going to do it?
Make an equation of C and then plot.
The problem now is we have the transfer function now, not in time domain, but in S domain. Yang ini. Ashraf.
So yeah, Prof.
How we go to plot?
In MATLAB,
Oh,
first declare as a Laplace
okay,
coefficient.
okay.
SDF kurungan. Yes.
Okay.
Okay, so then
E is equal to 4.8 divided by S plus 6.7.
yes.
Okay, enter. Lepas tu?
Lepas tu directly plot PLOT G dalam kurungan G.
Plot G.
Yes.
Okay, plot G. Tak boleh lah. Tak boleh. Boleh, tak graduan lagi kau. Najwa, tolong. How to plot the response? Najwa.
Yes, doktor.
Hai. Dah makan?
Belum.
Puasa. How to
Tak tahu
plot?
lah, doktor.
Step lah. Step by step.
Ada idea.
Step.
Okay.
Step G. Then you will get the graph. Tu dia? Nampak? Can you see the graph?
Yes.
Nampak, Prof? Prof, kalau guna F-plot boleh tak, Prof?
Boleh. Kita pakai plot sebab it's transfer function. Kalau pakai T domain, you generate the time range, then you plot okay. But for transfer function, you have to inject the signals. Step lah, step. Respond one word.
Okay, faham, Prof.
Aisyah Akram. Aisyah Akram.
Yes, saya, Prof.
How to identify from the graph the rising time, settling time, and time constant from the given graph here.
Kira balik.
Kira balik.
No.
You don't have to
Kan dekat
calculate.
situ.
You want to use the MATLAB function here. Right click.
Right click. Betul.
Grid. Grid. Then pick respond. Okay, situ. Rise time. To settling time. To transient time. To steady state. Situ.
Right click. Rise time. Settling time.
Tapi
Satu.
time constant tak ada. Macam mana? Macam mana kita nak cari? Time constant tak ada. Macam mana nak cari?
Sekejap letak tadi. Right click. Rise time. Settling time. Lepas tu.
Time constant. So we know rise time. Okay. 0.328 second. We know the settling time, which is 0.584 second. We know the steady state value or final value 0.716 second. So how are we going to find the time constant from this graph? Masya Akram. Kalau dapat ni, boleh belanja dia. Belanja makan. %63 multiply by
63% darab dengan 0.716.
berapa? How many? 63 divided by 100 multiply 0.716.
0.716. 0.45. Lepas tu
Wait.
kita
0.45.
0.45.
So find the amplitude lah, 0.45.
Then we plot from there and then tarik sampai bawah. Situ.
45.
Sikit lagi. Sikit. Okay. Atau
Sikit.
tekan situ.
Okay.
Garis sampai ke bawah time tu.
Tak payah.
Tak perlu.
No need. Dah tulis lah. 0.8 second.
Betul lah. Okay. Lepas tu
Skema budak-budak nak tarik bawah lah apa lah. Twitter tu dah bagi dah 0.148 second is the time constant.
thank you, Prof.
Okay. Lukman, faham tak Man? Lukman. You understand how to find the time constant?
Faham.
Rising time?
Tekan tu ni kan, right click ni kan?
Tak, ini time constant ni. You faham tak?
Faham. 63%.
Okay. Example. First order. Identify the constant, time constant, settling time, and rise time. So kita pakai apa? Kita pakai MATLAB lah Boleh? 50 plus 50.
Prof, untuk pakai MATLAB, untuk assignment nanti kita guna live script atau boleh buat dalam command window je?
Boleh, both boleh.
Both boleh Okay, thanks Prof.
Okay. Aisyah Syahira.
Yes, Prof.
Transfer function please.
Transfer function.
Next example.
50 over S plus 50.
Okay. How to plot the graph? Command.
Step function. Step G.
Step G.
Yep.
G. Step
No.
G.
There's a bracket.
Bracket. So you don't say bracket. So, can you see the graph?
No.
Okay. How to show the grid from this figure?
Right click.
Right click.
Yeah, right click on the.
How to find the final value?
Characteristic.
Steady state.
Yes. Steady
Final
state.
value and steady state is the same word. Okay. So final value berapa? 1. How to find the settling time, Shahira?
Right click again, characteristic, and click the settling time.
The value?
0.078.
How to find the rising time?
Again, characteristic and rise time.
The value?
0.0439.
But in here, there is no time constant. Can you give input how to find time constant?
Using the equation, it's the 63% of the final value.
1 over A, 1 over 50.
Yeah, 1 over 50.
Berapa?
0.02.
So if it's not given, like your assignment, so how are you going to find E? In the assignment, there is no transfer function, just graph. So how are you going to find E? So we just click here,
63%.
then monitor the amplitude 0.63. Can you see amplitude moving? Guys, can you
Yes.
see?
Yes,
Can,
yes,
Prof.
Prof.
661, 62, 63. Oops. So you have to do some stretching, okay, in order to get the accurate value. Okay. Okay. So what is the time constant here?
0.02.
0.02. Okay. Understand? Boleh?
Boleh, Prof.
InsyaAllah.
InsyaAllah boleh.
InsyaAllah boleh. Masya boleh.
Doctor, I have a question.
Yes, yes, yes.
Why for the poles we use 50 and not negative 50?
Pools.
Uh,
Ni. Ni. Ni.
yeah, for example, this one.
Kenapa?
So we just take A poles as 50, not negative 50. We don't need to change the sign.
Change the sign.
Ah,
I don't understand. What you say?
oh,
I don't understand.
A is poles, right,
Canggih
doctor?
sangat bah soalan kau.
A is poles, right, doctor?
Sekejap, eh. First, we compare with the KS plus A kan.
Oh, okay. I understand now. Okay. Thank you, doctor.
Kacau. Okay. Faham ya?
Faham.
So, kalau nak cari poles S plus 50 equal to 0 lah. So, the poles will be minus 50. Okay. So, in this case, A is equal to 50, positive. Sebab kita compare dengan standard dia. First order equations. Boleh ba? Herita, boleh ba? Herman? Herman?
Boleh, Doktor, boleh.
Boleh ba? Eh? Tak faham tanya ya?
Boleh, Doktor.
Second order system, 4.3. So, we finish first order, now second order. What is the definition of second order system? The system that has two poles. First order, the system that has one pole. Third order, system that has three poles. Okay, so general second order system is C over R. Okay, C over R equal to B S square plus AS plus B. So S square plus AS plus B is a quadratic equation. Everybody say quadratic equation.
Quadratic
Quadratic
equation.
equation.
Given C over R equal to 9 over S square plus 9S plus 9. So if input R is 1 volt and the Laplace is 1 over S multiplied with the transfer function. So this one we use the partial fraction expansion. Then we apply inverse Laplace, so we will get C of t. Panjang tu, eh? So it have a two real axis value from here. Okay, so this one have a two real axis. This quadratic, if you find the roots, roots. Tahu tak roots? Roots tu apa? Rita, roots. And Rita,
Yes, Prof.
what is roots?
The roots. What is roots?
Punca.
Punca.
Punca. Okay, so the value is minus 1.146 and minus 7.854. The nature of the number is a negative and real numbers. Everybody follow me. Negative and real numbers.
Negative and real numbers.
Okay. So since it is negative and real numbers, we call it as the overdamped response. Follow me. Overdamped response.
Overdamped
response.
Okay. So pulse, the behavior of the overdamped response is two poles at negative real part. Okay, which is minus sigma 1 and minus sigma 2. The natural response have two exponential, which is K1 exponent minus sigma 1 and plus K2 exponent minus sigma 2. Example number 2. You are given C over R, 9 divided by S square plus 2S minus 9. So what is the roots, Henrietta, for this quadratic equation?
-1 plus minus square root at J.
Yalah, square root at itu berapa?
Set at
Set at itu berapa?
set at 2.83.
2.83. The other one is minus 1 minus J
2.83.
So what is the nature number of these roots? Aisha Akram.
Natural number.
Sifat dia.
Overdamped.
Astaghfirullah. Complex conjugate poles.
Oh, complex conjugate poles.
Repeat after me. Complex conjugate poles.
Conjugate poles.
Everybody.
Complex conjugate poles.
Complex conjugate poles. Okay, take note. So the location of the poles is here. It's not on the real axis. Okay, is the pairing, positive and negative, imaginary. The real part is the same, -1, but the imaginary is different, which is minus Apa tadi Henrietta? Minus 2.83 ya?
Yes, Prof.
Minus 2.83J and positive 2.83J. And this behavior of the roots will cause the response become underdamped response. Everybody follow me. Underdamped response.
Under the response.
Okay, so this is the roots, and the natural response is C of t a exponent cos omega t minus sine. Okay, and there is a oscillation frequency omega d at the imaginary part of the poles. Okay, which is shown here. So for underdamped, it will exponential decay generated by real part of complex pole pair. Okay. Example 3, 9 over s squared plus 9. Okay. So R is 1 volt, Laplace 1 over s. So multiply, and then we can find that the roots, okay, this one s squared. What is the roots value? My Sarah?
The roots is J3,
Namanya.
positive J3 and negative J3.
Lama ni. Plus minus J3, okay? So you locate here on the top of imaginary axis. And then the nature of the response is oscillate. Okay, oscillate at constant envelope value until infinity. Okay, this response, we call it as the undamped response. Repeat after me. Undamped response.
Undamped response.
Under response.
Okay. Example number 4. 9 over s squared plus 6s plus 9. My Sarah again. What is the roots of this? My Sarah.
Saya nak kira. Jangan tu tengah kira. What negative J3?
Negative J3. Negative J3. S plus 3 kuasa 2 lah. S plus 3 kuasa 2.
Negative 3.
Negative 3 and negative 3 lah. Aduh, letih. Okay, faham tak? Faham gitu.
Paham, Prof.
Tidur budak-budak ni. Tak bantal, tak selimut, buka aircon, tidur je. Okay, so the roots is minus 3. So the number is integer. Because there is no decimal point, we call it integer and negative. Malay people say nombor bulat and negative. So you can see that the roots is at minus 3 and minus 3. They are superimposed. So this we call it as what? Aisha Soleha.
Yes, Prof.
Kalau dia bertindih ni kita panggil apa? In English.
Bertindih.
Bertindih.
Hmm.
In English. Poles are each other.
Overlap.
Aisha Shrira, budak Muar. Poles are ... each other. Aisha Shahira.
I don't know.
Oh. You don't know. You always don't know. Aisha Akram. The 3 Aishas.
Overlap.
Overlap. Bagus. Beri tepukan.
Tadi Aisyah Soleha dah bagi tahu dah.
Lambat.
Set tu.
Dengar dia cakap. Poles are overlap each other. Bertindih di antara satu sama lain, and we call this as a critically damped response. Repeat after me. Critically damped response.
Critically damped response.
Response.
MashaAllah. Okay. We have a rest first. Okay. Boleh. Rehat.
Prof,
10 minit dia soalan.
question last.
Oh,
So basically our assignment lebih kurang macam ni kan, betul tak?
in English lah.
Sama.
Because we have-
So basically our assignment similar with what you teach us today, right?
Yeah. Basically, more or less, yes. You are just given a data, 2 column of data, which is the time data and amplitude data. So when you plot, it will give response lah kan. Macam ni kan. Okay. Then you have a graph, something like this. So you have to identify the parameters value lah, settling time, the peak time, time constant, to get the mathematical model G of S. So I will conduct a free session of Zoom so that you can present to me, you can ask me, okay? Maybe during weekend, Saturday or Sunday, okay? If you request lah, your group request want to discuss with me, yes, I can help inshallah. Okay, just send a request, then I will create a Zoom link to give advice on your assignments. Boleh? Okay, rehat 10 minit, 10 minutes rest. Boleh dengar?
Boleh.
So we already look at the second categories, okay, second order categories. Over them, and them, critical them, under them, and number 5 is negative them. Okay, so negative them, you can put any value. Okay, S minus 1 plus J3, S minus 1 minus J3 is the example of the negative them, okay, which is shown in the slides here. Okay. Okay. So what is the value of the poles negative them response ini? Hello. Hai. Kalau itu kan Oh. Okay. So what is the value of the poles here in this pole 0 and mapping? Can somebody tell me? Hafiz, Nazim?
Negative 3J and plus 3J. Then
You must understand how to read these poles and zero mapping, Hafiz. What is the poles value in these poles and zero mapping? Hafiz tak tahu.
One negative 3J, one positive 3J.
Okay, so positive minus J3. Yan. Peace.
ya doktor.
Tidur ke?
Tak, sebab saya ingatkan tu zero line.
Tengok ni, zero is positive ni. Positive. We are in the right hand side. Okay, right hand side. I will explain.
Okay, doktor.
Okay, be careful. Careless mistake will cause an error. Right. Then the response will be like this. Okay, you start from zeros, goes to oscillate until infinity. Okay, or negative then become bigger, bigger towards infinity. Okay, unstable lah. So the conclusion is when the poles on the right hand side, system is unstable. The poles on the left hand side, system is stable. Okay, so we wrap up. This is the general form of the second order system. Okay, and this is the overdamp transfer functions, which will give you negative and real poles. Okay, and this is the response. It looks like first order, betul tak? It looks like first order. Shakila.
Yes, Doctor.
It looks like first order. Overdamp. Is it? No? Yes? Maybe? Second one is underdamp. Okay, so underdamp is you will get a -1 plus minus J 2.83. This one is known as complex conjugate poles. Complex conjugate poles. This one is negative real poles. Clear? Clear? And the third one is underdamp. Okay, undamp. So undamp will give you a complex pole. Okay, plus minus J3. Plus minus J3, complex poles. There is no real because the real is 0. So plus minus J3 and the response is oscillate till infinity. And the fourth one is critically damped, where the location of the poles here is negative and what? Overlap each other. Okay, the poles is overlap each other, negative and overlap each other. So we can conclude here the 4 response. Negative is not included because negative damp is considered as unstable system. Okay, so basically there are 5 categories. Okay, in the books is 4 categories. Oh, that is finished. Is it finished? Is it finished? Chapter 5A. So we move to 5B. Chapter 5B. Under 5B. Ada soalan so far? Any question? No question. So 5B, please open your slides, 5B. Okay. This is the response and stability analysis in the time domain. Okay, response specifications. So we learned already 4 categories of second order, which is undamped, underdamped, critical damped, and overdamped, including the negative damp, which is shown here, the response, the location of the poles, okay, negative and real for overdamped, complex conjugate poles for underdamped, complex number at undamped, and real and overlap negative at the critically damped. So you are given here, okay, for of underdamped response poles here by inspection, write the form of the step response of the system in figure 4.9. Okay, so if you look here, when we key in, we write the program, okay, for the response. So the C over R is 200 S square plus 10S plus 200. Okay. So we observe the response by using MATLAB. Okay. Aisha Shahira.
Yes, Prof.
Can you give me the example transfer functions just now? G equal to
200 over
200 over
S squared plus
S squared
plus 10S
and
plus
S
200.
200.
Yes.
And how to generate the graph?
Step bracket G.
Step bracket G. Yeah. Okay. Can you see the response?
No, not yet.
Okay. Right. Ehsan Aulia. Ehsan. Tak datang. Daniel? Daniel?
Yeah, Prof.
So by looking at the
sorry, Doctor, I'm here.
Ehsan is here. Ehsan. So by looking at the graph here, so what category is the second order response here?
Overdamped. Underdamped, Doctor.
Underdamped. Overdamped.
No, under, Doctor. Because it oscillates.
Right. Daniel?
Yes, Prof.
What is the peak time?
Peak time. 0.2.
0.2 something.
Yes, plus.
There you go. 0.239.
Yeah.
Okay. Sharifah, Khairunisa.
Ya, Doktor.
Tidur ke?
Tadilah.
What is the value of settling time? Approximate?
0.7.
0.8 something.
0.8
something,
Betul.
Oh, 0.7, betul. Awak bagus. 0.774. Okay. Nurul Shakila,
Yes, Doctor.
rising time estimations.
0.09.
0.09. Dahsyat budak ni. Macam mana awak tahu kan?
Ada lecture note.
Oh, you ada pakai komputer. Okay, right. And what is the final value? Izati? Izati,
1, Doctor.
what is the final value?
1.
Tak datang.
Hello?
Good, Izati.
Hello, Prof.
What is
1.
the final value?
1.
1. Yeah. Yeah, exactly right. Okay, so itu dia. Okay, to answer the question there. So it is a under them response. Oh, tengok kat sini. Betul lah, dia tahu. Right. So second order system, we have two important parameters in the general second order transfer function. The first one is the natural frequency, which is omega n, and damping ratio, which is zeta. Yesterday's I discussed with you, okay, the natural frequency or frequency of oscillation of the system without damping, or known as undamped natural frequency, okay, omega n. And the unit is radian per second. Damping ratio or zeta, okay, zeta, you have to practice how to write zeta. Zeta is the ratio between exponential decay frequency divided by natural frequency. Okay, so zeta. Okay, like this. Damping ratio. Okay, omega n is the undamped natural frequency. And the other one is the twin of omega n. We call it omega d, which is known as the damped natural frequency. Okay, please take note, zeta, omega n, omega d. Clear? Clear, guys? Ya, boleh. Tidur ke? Boleh tak?
Boleh ada.
So second order system can be transformed to show the quantities of zeta and omega n by considering the general system b divided by s square plus as plus b. Okay. So for poles purely imaginary, a equal to 0. Poles on the j omega axis, imaginary axis, is omega n square root b, and b is equal to omega s square. Okay, so we can find the roots here for quadratic roots formula, minus b plus minus square root b square minus 4ac divided by 2a. Okay, so zeta is equal to a divided by 2 divided by omega n. Then we can find the standard general second order transfer function, which is omega n square 1 over s square plus 2 zeta omega n s plus omega n square. So when we factorize this quadratic, we will get these roots. Okay, and these roots represent the poles of the system. For example, okay, just now I show you that the transfer functions Okay. (200) S square plus 10s. Okay. So which is equal to omega n square, s square plus 2 zeta omega ns plus omega n square. So omega n square sama dengan 200. Okay. Can you see what am I writing? Hello?
Yes, doctor.
Yes, doctor.
Can see, eh? So square root 200. Okay. Square root 200.
Uh, 10 set 2 or 14.1421.
14.
0.1421. 1421, yeah.
Radian. 2 zeta omega n equal to 10. So zeta is equal to 10 divided by 2 omega n. Berapa? Bagus?
Wait, doctor. I calculate this. 10 over 2, 14.1421. 0.3536.
Okay. So that is the value of the zeta. Okay. So with respect to the 4 categories of second order system, we can assign the zeta values based on the second order system categories. For example, zeta equal to 0, where it will give you complex poles at the imaginary axis. Okay, so zeta zeros, we call it as undamped. Then zeta between 0 and 1, we call it as underdamped because the poles are complex conjugate poles. If zeta is equal to 1, the poles are overlap, negative and overlap at the real axis. This one we call it as a critical damp. And then when zeta is greater than 1, it will give you negative and real poles, which is the overdamped response. So now, please remember this range. Okay, 0, 0 between zeta between 0 and 1, zeta equal to 1, and zeta is negative 1. Nurul Hidayah. Sorry, Rida Hadira. Rida Hadira.
Saya, Prof.
Tak dengar suara, macam suara gemas.
Saya, Prof.
If zeta less than 0, what category? Undamped, underdamped, critical damp, overdamped? Zeta less than 0.
Underdamped.
Kemudian? Rida Hadira.
Underdamped. Less than 0.
Zeta less than 0. Category, what category?
Tak ada.
Tak ada. Tadi dia cakap. Rida Hadira.
Negatif.
Negative?
Negatif.
Negative?
Negatif damp.
Negative damp. Okay. Right. So you are given 3 examples. find the zeta and omega n. So use my method just now. Use my method just now. Oops. Okay, so kita buat sama-sama. Ya, okay. Pokemon 10 student not coming. Farid, Rizwan?
Yes, Doctor.
Omega n?
Omega n. 12.
Square root 12.
Square root. So, okay.
Tidur lah tu.
Yeah.
Tidur.
3.46.
46. Radian?
Radian per second.
Zeta? Apa?
1.15.
1.15. 1.15. So category? What category?
Category over them.
Over them. Nasib baik boleh. Letak berdiri atas kursi. Fatur Zaki. Wah, Fatur. Mana kamu?
Yes, Dokter. Halo.
Omega n?
Omega m
Square root 16 dong.
Itu plus minus 4. Iya, Dokter. Plus minus 4. 4. Just 4.
Kamu tidur ya? Kamu tidur kah?
Tak.
Zeta?
Halo. Zeta itu 8 bagi 2 omega n. Berarti 8 bagi 8 1, Dokter.
8 bagi 2 multiply
8 bagi 2
8
4.
bagi 8. 1 dong.
8 bagi 8 1.
Iya. Berapa
iya,
kategorinya? Critical kah? Critical? Zeta 1 critical dan. Nur Najwa?
Yes, Doctor. Yes.
Omega n?
4.47
Unit?
radian per second.
Zeta?
.89
Kategori?
under them.
Pandai lah. Dah boleh lah buat assignment. Dah siap?
Belum.
So this is the plotting lah. Plotting zeta greater than 1, zeta equal 1, and this one apa? Zeta. Okay. Sama ada answer this questions answer. Okay, yang ini Herman, Benedict.
Yes, Doctor.
Omega n?
36.
Berapa?
6. Yeah.
Zeta?
It, 0. Yeah.
Itulah 0 point.
0.35.
Kategori?
Under them.
Okay, bagus. Yang ini Aisyah Soleha pembagian.
Oh, yes, Prof. 20.
Radian. Zeta
0.3.
Anda?
Under them.
Aisyah Syahira?
Yes,
B?
Prof. B. Okay. 30. 30 radian per second. Yes.
Zeta?
1.5.
1.5. Kategori?
Over them.
Aisyah Akram? Omega
Yes,
N?
Prof. Omega N said 15.
15. Zeta?
Zeta 30 bagi dengan 2 darab 15 dapat 1.
Kategori?
Kategorinya adalah critically damped.
Maisara?
Yes, Prof.
Yang ini D?
25. It is 25.
Zeta?
0.
Hah? Zeta?
0.
0. Kategori?
Negative. Under them.
Ish. Andem. Zeta kosong andem. Maisara? Betul tak?
Betul, Prof.
Okay. Right, so itu dia. Ini dia jawapannya. Under them, over them, critical them, and them. Right, kita dah buat. So this is the derivations of the second order system where you have the standard second order. Can you remember this equation? Omega n square over s square divided by 2 zeta omega n s plus omega n square. Hafiz, can you remember this? Hafiz Nazir, can you remember?
InsyaAllah, sebab tadi kita dah buat exercise.
Okay, Hafiz boleh ingat Hafiz boleh ingat
InsyaAllah.
Oh, Hafiz Quran kan?
Tak.
Hafiz 10 surah.
InsyaAllah.
Jadi using partial differential equation, partial fraction expansion, kita boleh derive, okay, for the case of K1, K2, and K3 by taking the inverse Laplace transform. Okay, so you don't have to remember the derivations. The important thing is the zeta values will give you a different graph. That's why in assignment, some of you get zeta power 0.1, zeta 0.8, 0.6. Okay, so many variations of second order system. So what is the rise time in second order definition system? Is the time required for the waveform to go from 10% to 90%. Same like first order. Peak time, the time required to reach the first or maximum peak. Overshoot is the amount that waveform overshoot from the steady state or final value. Okay. For example, Okay. Okay. So this response like this. This one is 1.2. And what is the overshoot here? Overshoot here is in Malay is terlajak puncak, terbabas, overshoot. Yeah. So overshoot dia adalah 1.2 minus 1 divided by 1 multiply 100%. Berapa? 20% overshoots. Okay. And settling time is the time required to reach and stay plus minus 2% of the steady state value, which is shown in the second order time response spec here. Okay. Time rising time, peak time, settling time. Okay. So we can derive here overshoot C max, maximum, multiplied by CF, final, divided by C, final, and all of this multiplied by 100%. Okay? Understand? Guys, understand?
Yes, Doctor.
Okay. Evaluation of peak time is we can derive by differentiating C of t, find the first zero after t equal to 0 and assume 0 initial conditions. Okay. By using this formula, you can get overshoot percentage, and this relation can be written in this graph. Okay, can be visualized, sorry, can be expressed in this formula. Overshoot percentage is equal to minus exponent minus zeta pi divided by square root 1 minus zeta square multiplied by 100. Remember this formula. Remember, okay? And the graph to show the overshoot against zeta is shown in this standard graph. So this is the standard graph given in the final exams. Okay. Sharifah Herunisa.
Yeah, Doctor.
If the overshoot is equal to 40%, what is the estimated zeta from the graph? Overshoot is 40%.
0.3.
0. Izati?
Yes, Prof.
When the overshoot is equal to 10%, what is the value of zeta?
Uh, 0.5.
0.55. So that's the way we calculate the zeta. You can remember formula and you can use the graph. Both will do. Basically, they have three methods. One is using overshoot formula. One is using zeta formula, which using a natural logarithm, and the other one is using a standard graph. Okay, all method can be used to find zeta and OS. For TS is the time C of t reach and stay within plus minus 2%. Okay, so we can derive it. So the formula is 4 divided by zeta omega n. Or 4 divided by real part. Okay, modulus real. Okay, zeta omega n is the real part of the S-plane. And this one can be represented by this S-plane for complex conjugate poles. Okay, complex conjugate poles, which is under them, kan? So the length between the origin towards the complex conjugate pole is omega n. How to find zeta from this graph, from this S-plane? Aisha Akram.
From this plane,
Which is, you have to use cos theta equal to zeta. Okay, so zeta equal to inverse cos.
A over H.
Sorry, theta equal to inverse cos zeta. The angle here, okay? The angle. So you're given this transfer function, so omega n is equal to 10 radian per second, and zeta is equal to 15 divided by 2 divided by 10. .75 is under damped response. Okay. Okay, this is all the important formulas. Peak time, overshoot, and zeta plus settling time and the graph. Okay, in order to solve second order problems and second order solutions. Not to forget the rising time. Okay, so rising time is omega n TR equal to 1.76 zeta cubic. Zeta kuasa 3 power of 3 is zeta cubic minus 0.417 zeta square plus 1.039 zeta plus 1. And this is the standard graph. Okay. Aisha Shahira.
Yes, Prof.
Can you give me the equation of this curve? Equation, yeah.
Equation.
Curve ni. Atau Henrietta, what is the equation of this curve? Henrietta?
Is it the equation at the top of the screen, Doctor? 1.76.
Inilah equation.
Yeah.
Yeah. Okay. Okay. So you are given this S-plane, find TP, overshoot percentage, and TS. Is under damped, kan? Under damped case. Complex conjugate poles. Okay. So the poles value is -3 plus minus J7. So find the zeta. Aisha Akram. Macam mana nak cari theta tu?
Theta cos theta equal to A over H. So
No. Find theta first. Theta is arctangent, kan?
Boleh?
Berapa? Arctangent 7 divided by 3. Angle berapa?
Radian ke angle?
Degree.
66.8.
Zeta is equal to cos theta.
Yeah. Cos 66. Cos 66.8 is 0.39.
Betul lah, under them kan? Kan?
Hmm,
It's between 0 and 1. So what is the value of omega n? Asha, omega n.
Omega n.
Hmm.
Omega n is set ni.
Set.
Sama lah. J7.
Oh,
J7.
0.397 square. How much?
0.397 square. 7.62. 63. 7.63.
Radian per second. Correct, eh? 7 divided by square root 1 minus 0.397 square. Betul? Betul?
Betul, Prof. Cak. Okay. Tak apa.
Syakila. Yes apa?
Yes, sir. 4 over.
How much?
Okay. 1.34.
Peak time? Syakila. Syakila. 3.14 divided by 7.
0.447.
And lastly, the overshoot.
Doktor.
Exponent minus pi divided by zeta multiply by apa formula tadi? The formula. This formula. This one. Insert the zeta value multiply by 100. Aisha, can you help me?
Macam siapa, Doktor?
Ni zeta.
Zeta.
Zeta is
Exponent in negative
0.397. Yeah.
.397 bagi dengan set 1 minus 0.397 kuasa 2 duk ada pi. Kejap Doktor. Darab dengan 100 dapat 25.69.
Okay, so we can draw the equivalent graph. Okay. Okay. 25.69. Overshoot. Okay, peak time. Tadi Syakila cakap 0.44. Settling time. Tadi Syakila cakap 1.34. Okay, and then what else? Zeta and omega n. Okay, so this is the plot. Ini roughly ya. Okay.
Doktor,
Yep.
yang rest time tu.
Rest time tak payah. No need.
Okay.
No need because rest time is not in the scope of questions. So if they don't ask, you don't have to answer. Okay. See, same Sama tak jawapan? Is it same answer? Hello guys.
Same, tapi lari sikit.
Apa? Halalan taibah. Ada tolerance penerimaan. Any question? 350 already.
No question. Lapar.
Apa? Any question?
Prof.
Soalan. Aina, Najiha. Oh,
Saya nak tanya.
Yes.
Apa kalau ada what decimal places should we give in the answer script?
No problem. No problem. Kalau jawapan, if the answer is the answer is 0.44 seconds. So you get 0.41, 0.42, okay. As long as you didn't get 44 seconds. So 44 seconds is wrong lah.
Okay, Prof. Thank you.
Any questions? Pak, ada soalan Pak?
Oh, tak ada soalan, Doktor.
Nak makan
Nak makan lah ni.
Okay lah. Okay, thank you very much. Okay, I see you next week, inshallah. On the slide number 52. Okay. Thank you very much.
Prof. Thank you.
Thank you, Prof.
Thank you, Prof.